Hi, I'm Kevin, the developer of Starcom Unknown Space, and this is a short devlog demonstrating how the game's world space coordinate system works. While doing some experiments with Unity's ECS system, I recreated a version of this coordinate system, and I've written about it before, but I realized this prototype had the right debug elements implemented to show how it works visually. So here is our, quote, ship flying around through space. And when we go out of bounds, you see that we wrap around to the other side of the square, sort of like how old school asteroids worked. And also happens over here. So go around and around. And if we look on the right side of the screen here, we can see the actual position of our ship in the game engine's world coordinates. As a quick aside, for reasons, Unity considers up to be the y-axis and x/z to be the horizontal plane. The naming of axes is arbitrary, and this assignment makes some sense in certain contexts, like 2D platformers or UI, but it does create some weirdness for a top-down game. Either I use XY for the plane of space and run into confusion when using Unity methods and enums, or I use XZ for the plane of action and deal with the fact that it seems counterintuitive. So I've decided on the latter. Okay, back to our ship. As I said, you can go off the edge, and you'll notice that we go from positive 250 to negative 250-ish as we go around, and vice versa. And you'll also notice that there are these two numbers in the lower left corner of the square that go up and down like counters for how many times we've wrapped around. But we are perpetually trapped in this central green square. And if we zoom out, we can see that we're surrounded by 8 other green squares in kind of a tic-tac-toe grid that we can never enter. Fly around a little bit more, and at a certain point we see that suddenly a couple of, quote, planets and asteroid field appear in 2 of the other green squares, which might give you a clue as to what's going on. The game is keeping active all objects that are in the same sector as the player or in adjacent sectors. This way the player never sees objects suddenly pop into existence in the real game because, as I mentioned earlier, we keep the sector size large enough that the edge of view is never more than 1 sector away. The game still knows the important persistent information about the objects, so in-game we can show faraway stuff in the map view, and in reality these objects always exist in the game's data, but the game doesn't bother creating all the complex data necessary to simulate physics, render meshes, for example, the individual positions, velocities, and so forth of the, quote, asteroids. But the important persistent information is exactly the same as what goes into a save game. So if you open up your save in a text editor, you can see what the game thinks it needs to know to keep the world convincingly persistent. Let's see if we can find someone's save that they've submitted. There we go. Let's see. Okay. And so this is an actual save game from Starcom Unknown Space, and this block here is the data representing a asteroid field, and it has a lot less data than would be necessary to actually simulate in game. There's nothing about masses or velocities or transforms, meshes, and so forth. It just says, you know, the maximum number of obstacles, how far away they can be from the origin, what their coordinates are, and how many there currently are. Supercoordinates are a custom value data type used by the game to track persistent objects throughout the game. These consist of the XZ position relative to the center of the sector And for the player's active sector, that would be corresponding directly to the position values, what the game world thinks of as the world position. For neighboring cells, these would be offset some multiple of the sector's size. When we cross a sector boundary, the game picks everything up and moves it one sector over. So the player's sector always has its center at world position 0, 0. Going back to the coordinates, the UX values, integers, represent the sector address or sector position, which are these numbers in the lower left corner of the sector or green square. And finally, there is a universe value that allows for the game to keep objects in non-contiguous regions. So you could have, for example, Starcom space and then unknown space, two regions which you cannot fly directly between. There are multiple reasons for using this coordinate system. For one thing, it keeps things nicely spatially organized in the authoring files and saves. It also helps for quickly figuring out what data needs to be loaded and unloaded as the player moves about. But a third very important reason is that game engines typically use 32-bit precision floating point numbers for physics and rendering. Unlike integers, these numbers can store both minute fractions as well as huge values while using the same number of bits. They accomplish this trick by having less precision at large values. So while you're near the world origin of 0, 0, they might be able to precisely place an object to 5 or 8 decimal places. I'm just pulling these numbers out of air. But at world 1 million by 2 million, they might only be able to place an object precisely to a single decimal point or less. So at that range, objects would appear to jitter about and display all sorts of simulation and rendering errors. By using this super coordinate system, nothing is rendered or physically simulated more than 10,000 units from the world origin, or twice the sector size. Going back to our zoomed out debug view, the green squares represent the sectors that are active and fully actualized in the game engine with physics and meshes and everything. The blue squares are the sectors that contain, that the player has visited or seen, and contain stuff that the game knows about and could potentially show on the map. It will need to save this information. It can potentially manipulate it via the mission save system, but their contents are not modeled under physics and are not rendered. The gray squares are sectors that do not exist at all because they contain nothing and the player has never visited them. This has a convenient feature that because the player has never seen them, the player could decide at any time to put something in them. So perhaps if the player discovers some derelict that reveals the lost tomb of Okjuk, then the game can sneakily put a star system into a nearby empty sector, and then the derelict's log can say, oh, here are the coordinates, and it's somewhere we've never explored. How about that? Finally, for purposes of this demonstration, I've kept the camera stationary at the world origin. So as you can see in the camera's transform, the position is constant at 0, 0, where y is the camera's elevation above the player. It never moves as the player flies from sector to sector, but everything in the world gets moved about. So let's see what happens when we have the camera follow the player. And as you can see, everything looks exactly as if we inhabited an infinite open world universe, which is exactly what we wanted. Okay, well, that's it for this video, and thanks for watching.